We're going to start here one of the very simple article, most simple article from PD, which is known as equation solvable by direct integration. So now we are moving to the second part of the topic here. In the last session, we learned about how to form the differential equation by eliminating either arbitrary constant or arbitrary function. But here now, when we now we have to do the reverse part. When we have to solve the differential equation, the final answer will contain either arbitrary constants or arbitrary functions. So these examples, whatever the first four examples you are observing here, they are very straightforward. They are based on the direct integration. And the question comes only for 2 marks there. Here about in every question paper, you will have one question of a 2 marks on this article in old question paper. Okay. So before we proceed here, you should know what are the constants of integration of partial differential equation. We'll come to that first. Let I tell you, let I give you some function. Suppose we have z is equal to x square plus xy plus y square. Can anyone tell me what is the value of dou z by dou x?
2x plus y plus 0.
2x plus y plus 0. Very good. Okay, so that about a simple differentiation of algebraic terms there. But now suppose we have to again want that function z back here. This function we want it back again. And suppose we don't know what is z there exactly. Okay, this exact z we don't know. Only we have this value of dou z by dou x, and we want the function z. So we can integrate it partially. That means we can integrate z with respect to x, treating y like a constant. So that is known as a partial integration. Okay, so we are integrating partially like that. So integration of z with respect to x, partially treating y like a constant. So we get now, if you observe, integration of dou z by dou x is a z. Integration of a 2x with respect to x is like 2x square by 2. So 2 gets cancelled, we get x square. Integration of y with respect to x is yx or xy, is it? Because y is like a constant.
Yes,
But
sir.
that's one only. There will be a constant of integration now. The constant of integration will never take plus c now. The plus c is okay. That is only when you are integrating ordinary differential equation like dy by dx. If you integrate dy by dx with respect to x, that time the constant of integration is just c there. But in partial, when we integrate this z with respect to x partially, assuming y as a constant, we should say here function of y. I hope it's clear. Why I am writing f of y as a constant of integration? Because as we are integrating with respect to x, y is treated like a constant. So constant of integration is a function of other variable. Like we are integrating with x, so constant of integration should be the function of y. And this is the most general solution. Actually, this is the general solution. And in that general solution, whatever you have this is the particular solution where the value of that f of y is a y square. Value of f of y is a y square. So whenever we don't know the primitive, and we have this directly the differential and we integrate, we never come to know what should be that f of y. So that f of y only we can find out if we have some initial condition. But if there are three different variables, yes, if there are three different variables, then as we are integrating with x, and suppose that z is a function of x, y, and w. Say x, y, w. Okay. And now, if there is a dou z by dou y, and we are integrating with respect to, okay, say dou z by dou x is given, and we are integrating it with respect to x. So the constant of integration should be the function of y and w. Because as we are integrating with respect to x, as we are integrating dou z by dou x with respect to x, we are going to treat y and w as a constant. So function of yw is a constant there. Function of yw is a constant. But don't worry, in this topic we have only one thing: z is a function of x and y only. Z will never be the function of more than two variable here in the PD there. Okay. So first article is very simple. Just we have to integrate it one by one. We'll come to this part and one by one to these examples. Okay. Okay. Question number one here. We are given solve. What is the order of this differential equation? This is a
3.
third order differential equation. And what about degree? Degree
One.
is
1.
1, correct. So it is third order mainly. We are interested in order later on because depending on order, we have different methods there. Okay. Mainly first order, first degree have a different method, and later on then higher order have a different method. Okay, so this is the third order differential equation, and our aim is to find the z or find the solution of this differential equation. So step number one, we can rewrite this equation, the differential coefficient on one side and other on the other side. So we can write it here. You'll observe dou cube z by dou x square dou y is equal to minus of 18xy square minus sign. So it's not compulsory to take these terms on the other side. You can keep on that side also. Now tell me, to convert this third order derivative into z only, what should be the order of integration? First, we should integrate with respect to, yes. What should be the integration of this first with respect to
Sir,
x or
first
y?
we will respect
Y,
y,
sir.
sir. Y, sir.
Y. Okay, very good. But that's not correct. Okay, so it should be with respect to x. Yes, Rishan, correct. But why not y? Actually, this is y is correct only when you want to differentiate. Suppose you are given, I will write it here. Suppose you are given here x cube y cube, and you have to calculate this, you have to compute this. Then what you will do it, you first calculate dou z by dou y. Step number one, you will calculate dou z by dou y because you order will go like this from inside to outside. Then you will differentiate that dou z by dou y with respect to x. You get dou 2z by dou x dou y. Okay, and again you are differentiating with respect to x. You will get dou cube z by dou x square dou y, and then you will get the answer. So that answer you will get in three steps. First you will calculate dou z by dou y, then with respect to x and again with respect to x, and you will have the answer. But in this case we have to remove this operator. So to remove the operator, we remove from this to that. Okay, this side to that side means first you have to remove the outer operators and then the inner operator. So the outer operator is a dou by dou x. So this equation we have to integrate two times with respect to x and then with respect to y, and we will get the answer. Okay, so let me do it. Any doubt here? Order is clear?
No, sir.
Very good. So let I say integrating with respect to x, treating y as a constant. So this gives us dou 2z by dou x dou y now. Only dou x dou y will left. Okay. Because one integration is already done on LHS. Now on RHS, can you tell me the integration?
Minus 9x square y square
Very good. Minus 9x square y square and
plus 2 cos 2x minus y.
very good. 2 times cos of 2x minus y.
No,
Very good.
sir. Cos of 2x minus y by 2.
So by 2.
Yes, very good. My mistake. Yeah.
Yeah, sorry, sir.
Yes. Yes. No issue. So these things happen generally in confusion in derivative and integration. So should not do these silly mistakes. So upon 2 is there. Only that much? Is it? Only that much?
So plus Fy.
Plus f of y. Very good. That's correct. So I'll say plus f of y. That's a constant of integration. Don't forget to write the constant of integration. Now that f of y itself can involve the constant also, like suppose f of y is like y square plus 2y plus 5 or y square plus 2y plus c. So that's there will not a single c only. Instead of that c we are writing f of y. That's good. Why we are written f of y as a constant of integration? Because we integrated with respect to x, treating y like a constant. Treating y like a constant. Good. So next step, again integrating with x. Again integrating with respect to x. So to remove this outer operator, actually dou by dou x, so we get only dou z by dou y. Now we left only dou z by dou y. What's the integration of this? Yes,
So 3x cube y square.
very good. Integration of this part.
Sine 2x minus y by 4.
Sine 2x minus y upon 4, correct. Now what about integration of this?
So 2fy.
So this would be remain constant.
Not correct.
2fy.
F dash.
F means it will be only multiplied by x. Sir.
Correct. So it is x f of y. Because f of y is like a constant. Constant integration of constant is constant into that variable. So x f y. Okay. So x f y plus. Is it only the answer? There should be the constant of integration now.
So fy.
Again, the new fy. So again, no, so I will take this as f1y, and I will say this is f2y. Okay, so I'm written f1, f2. The reason is there are a number of constants coming. So to differentiate them, so either fy, gy, hy you can use it, or f1, f2, f3 you can use it. Last step now. Now integrating with respect to y. Now integrating with respect to y. So z equal to. Last thing is we are integrating with y now. What is integration of first term?
Minus x cube y cube.
Minus x cube y cube. Yes, correct. That is the first term. Integration of this. Integration of sine. Yes, Akash.
So plus cos 2x minus y by 4.
Okay. Yes, correct. Cos of 2x minus y upon not 4. Yes, 4 only. Correct. Very good. Because that minus minus become plus. Okay, good. Now what about integration of x upon y with respect to y?
X upon dash y.
Yes, x f1 dash y. We are integrating, and why you are writing derivative? Huh? Yes, Asif, you can talk now. Asif, Asif, you are not audible. Okay, so what about integration of x upon y? One. So we don't know f1 itself. This f1 of y can be a y square, f1 of y can be a sine y, it can be a log y. It is general function. So we can't say anything about it. There are two ways of writing it. You can say x into integration f1y dy. Okay, write in simple form. Or you can replace it by capital F1y, where capital F1y is integration of small f1y. So these are the two ways. So if you are not interested to write that capital, so you should say like this. Plus the last term. Plus, yes, only the last
fx.
fx. Take f of x or f3x. Okay, anything you can take. So that is the end of the question. So we got that answer. Sometimes this integral of f1 of y dy can be replaced by capital F1y and capital F2y, which indicates that is again some function, function of y. Depending on small f1 and small f2, we have that capital F1 and capital F2. So this is the general solution. What we got here? How many arbitrary functions involved in the final answer? How many arbitrary functions are there in the final answer? It's not two, Asif. There are three, f1, f2 and f3. Okay. So There are three arbitrary functions f1y, f2y, and f3x. These arbitrary functions are nothing but they are constant of integration, and number of arbitrary functions are always equal to the order of differential equation. Number of arbitrary functions is always equal to the order of differential equation. So when you complete it, tell me. We'll move to the next question then. Okay, done. Very good. Question number 2 is on the screen. You can complete it. It is exactly similar to the first. Yes, can anyone tell me the step number 1? The integrating with respect to x. Integrating with respect to x, we get dou 2z by dou x dou y. Yes, what should be the answer?
Sir, sine 2x plus 3y by 2.
Okay, nice. Only that much.
No,
Plus
sir,
Fy.
Fy.
Plus f1y. Okay, so just like exactly previous. Again with respect to x. Integration of this sign become a minus. Lastly now, integrating with respect to y. Integrating with respect to y, the final answer will be integration of minus cos is a minus sign upon 12. Now I'll write this answer in little different format. It is x into, I will say, capital F1y plus capital F2y. This is capital F1 and capital F2. They are integrations of their small f1 functions plus f3x. This is another way of writing the solution. Instead of integral sign, you can write this way also. Both way they are correct. That's the final answer. Three arbitrary functions corresponding to third order differential equation. So once you complete, again tell me, we'll move to the third question. Done. Question number 3 is on the screen now, which is again a very simple question. You can finish quickly. Tell me the step 1. We should integrate with respect to
Y.
y. Correct. Integrating with respect to y, we will get dou z by dou x equal to x2 plus
Fx.
f1. Now integrating with respect to x, we get x square y square by 4. Now we are integrating with x. So we should say, is it okay? That's correct. Very simple, very straightforward here. Not difficult at all. Yes, two arbitrary function, correct. Because it's a second order differential equation. Okay, done. So one last question on this type. So observe the question is now different. We have the question solve dou 2z by dou x square plus z equal to 0. Okay, so you focus on differential equation only first. Then we have given some initial condition at x equal to 0, z is e raised to y. At dou z by dou x, or at x equal to 0, that dou z by dou x is 1. So that initial condition is also given, but we'll think on that later on. Right now the differential equation which we are given is a dou 2z by dou x square plus z equal to 0. Yes, anyone? What should be the first step? What should be the first step? All first three previous examples, we have dou z differential coefficient with x and y only, so we can integrate it directly. But here that integration is not possible. Just if you compare this with our LD with a constant coefficient, we have like d2y by dx square plus y equal to 0, d2y by dx square plus y equal to 0. So we can solve in that way only. Okay, we can say let dou by dou x is a capital D. Okay, the operator dou by dou x is a capital D, and we get this one. Can we write like this? If d is a dou by dou x, it is a d square z plus z equal to 0. So this is just like our getting the complementary function of this differential equation. So if we write its auxiliary equation, the auxiliary equation will be d square plus 1 equal to 0, and we have to find the root. So the roots are here. You will observe these roots, d square plus 1 equal to 0. First of all, yes, d square plus 1 is equal to 0. So d is equal to plus or minus I are the root. Now whenever d is equal to plus or minus I are the root, how we write a complementary function? Suppose this is the roots of our ordinary differential equation. We write its yc or complementary function as a c1 cos x plus c2 sin x, because e raised to alpha x, that alpha is a 0. This is for ODE actually, ordinary differential equation. What will be the change? We are not writing the solution for ordinary actually, we are writing it for partial differential equation. So the change that we have is the C1 and C2 are replaced by arbitrary function. So what should be the values of C1 and C2? Which function it should taken? Yes, anyone? C1 and C2 should be the function of
Sir,
Y.
y.
y, correct, because it is actually a differential equation in x. We are treated y like a constant, so we should say f1y cos x plus f2y sin x, and that becomes a complementary solution. Okay, so that is a complementary solution. I will show you here. So this is f1y cos x plus f2y sin x, and that's a complete solution. Here is the end of the first part. Actually, if the question is only that much, solve this one. So this is the solution. But question is not only that much. There is one extra part we are given. X is 0, then z is e raised to y. X is 0, then dou z by dou x is 1. Okay. So these actually can be used to find out the values of f1y and f2y. Actually, these these are known as the initial condition which used to find out the values of arbitrary function of the solution. So let me replace x by 0 here. If x is a 0, what is the value of cos 0?
1,
Cos
sir.
1,
sin 0?
0.
0.
Okay, so cos 0 is 1, sin 0 is 0. So we get f1y equal to z. But what is that z? Z is e raised to y. So f1y is e raised to y we get. Okay, so if we replace these values, we get one of the constant, that is the e raised to y. Then we'll replace there. And now we'll calculate dou z by dou x first. And then again we replace x by 0. And we get the value of f2y. So let I show you this calculation. So the next part, we are given x equal to 0, then z is e raised to y. So this indicates that the meaning of this is z of 0y. When x is 0 and y as it is, then value of z is e raised to y. So at x equal to 0, z is e raised to y. That is the meaning first. And when you replace, we get f1y is e raised to y. F1y is e raised to y. Now we'll calculate a partial derivative. So first of all, we replace that f1y value here, e raised to y cos x. And now we'll calculate this partial derivative, dou z by dou x. Dou z by dou x of this, e raised to y as it is. Derivative of cos x is a minus sin x plus f2y cos x there. And now we'll replace again x by 0 and that dou z by dou x by 1. Dou z by dou x equal to 1 when x is a 0. So replace x by 0 and that's 1, and we get that answer. We get that required answer there. And here is a final answer. This is the final solution is actually free from arbitrary function. That is a particular solution. This solution is known as particular solution which satisfies some initial conditions. If anyone have a doubt, yes, you can ask.